All right, we're back with 8.3 and we're going to look at the compound interest part of this. Okay, so compound interest, we have the formula A equals P times the quantity 1 plus R to the power of X. Okay, so this is a special type of exponential growth. We're going to continue to talk about exponential functions. This is a special type of exponential growth. Okay, compound interest is about the time, we have to know the time that interest is compounded determines when the account is credited. So we have some terms that you need to know. Annually means once a year. Semi-annually means twice a year. Quarterly means 4 times a year. Monthly, it's going to happen 12 times a year. And daily is 365 times a year. Okay. So some things to know about compound interest, the formula. Okay, so again, the formula is A equals P, so times the quantity 1 plus R to the power of X, where A is the account balance after so many years. So this is like our final account balance. You might write like final account balance. P is the principal amount. That's the money that you put in, the money invested. You might say the money borrowed could be another one. That's the principal borrowed. You can't even read that. My chicken scratch. Okay. So that's the money borrowed, invested or borrowed. You still can barely read it. Sorry about that. X is the number of periods. Okay, so X is this stuff. Okay, the number of periods. And R is the periodic interest rate, and this is always as a decimal. Okay, that's always as a decimal. Now, if there are n compounding periods in each of t years, then your R is going to equal your APR divided by n, and your X is the number of times, okay, times t. So if there are n compounding periods in each of the 10 years. So we'll talk about this a little bit more and hopefully help it make sense. It's not the easiest thing, but we're going to have a worksheet working on it. So if we have, let's look at a couple examples. 3% interest compounded annually. That means we're going to have A of t. Okay, because we don't know for the time there. So A of t. So that's going to equal P times 1. So we're following our formula, plus 0.03 because it's 3%. That's equal to 0.03. Okay, so that's our R. Raise to the power of t. Or this is, and then that equals, if we simplify it, right, we added these two together, so we get P times the quantity 1.03 to the power of t. Awesome. So this again is annually. Now, if we look at this 3% interest compounded monthly, it starts off similar. We have a to the power of t. It's going to equal P times the quantity 1 plus. This is where this change is happening that we're talking about here. Okay, our R is going to be the interest rate. Okay, the annual percentage rate, APR, stands for annual percentage rate. Okay, so, or our rate. Okay, that's our APR here. So it's our APR divided by n, the number of compounding periods, right? N is the number of compounding periods. Since it's monthly, it's 12 times a year. So this is times 12, or 0.03 divided by 12. Raise to the power of 12t. I need to put the t in there again for how many years. Sorry for that typo. Then we add these and we get P equals 1.0025 to the power of 12t. So there's a lot of components to this special compound interest formula. So let me clean this up a little bit so we can do example 4. Okay, so Mr. Minzik invest $10,000 in a CD, earning 3% interest compounded daily. We're supposed to A, write an exponential function modeling the value of his investment after T years, and then use the function to find the value of the account in 25 years when he retires. Okay, so let's look at this. We need to identify our components here, right? Our formula is technically, so we're going to have A of T years, equals P times 1 plus R to the power of X times T, is how we might look at it, to think about it. So we need to identify some of these things. We do not know A, like the final account balance. We do know the principal. Okay, so our principal, our P, is how much he invested. He invests $10,000. All right, then we need our rate. Okay, in this case, he has a 3% interest rate compounded daily. Ooh, so 3% is equal to 0.03, and it's compounded daily, which means 365 times, according to that, which means our R is going to be that APR divided by N, the number of times it's compounded. So that's 0.03 divided by 365 is where that's coming from. Then we have an X. Okay, the X is the same thing as that, I guess what I wrote here is N. Because remember, our X is equal to the N times the T. Well, we don't know. We know the N is 365, but we don't know the T yet. We're assuming because we're doing A, okay? And then when we do the next one, we do know T is going to equal 25. So I hope that makes sense, because we do know that this is going to be 365 times 25, but we don't want to put that in the first problem in example A. Okay, so let's get to A. Okay, because A is where we write the exponential function modeling this. Okay, so we've got our exponential function here. So we've got A of T equals P, so 10,000, times 1 plus our R, and our R is 0.03 over 365 raised to the power of our X to T. So our X, so I guess it shouldn't say X to T there, huh? Depends on how we look at it. Because this one's it can be a little misleading and a little hard to follow sometimes. Like this one breaks it down a little bit nicer so we can see it all. So it's the X times the T, but anyway. So I'm going to go ahead and put 365 and then the T. All right, that is example. That's the answer to A. We wrote the equation. You could simplify it, but you wouldn't have to. All right, so then B says to use the function to find the value in 25 years. All right, well then that's when we change this part to 365 times 25. So what's the function of, what's the account balance in 25 years? So A of 25 is going to equal 10,000 times 1 plus 0.03 divided by 365 raised to the power of 365 times 25. I do hope you bring a calculator to class, a scientific calculator, so that you can calculate these and not have to do it by hand. Because then you can put all of that in the calculator, or you can show some steps. So our account, our A of 25 years, is going to be equal to, I'm going to put a dollar sign because it's my final answer, $21,169.35. So if this man, Mr. Menzik, invests $10,000 in a CD and he never touches it for 25 years, it will be worth 21,000. So he will double his money, but it's going to take 10 years to do it. Well, he'll more than double a little bit, and it's going to take 10 years for him to do that. All right, so again, we're going to have a worksheet in class to go over this. We'll probably do a few book problems as well, but have a worksheet to go over to get some more practice with the compound interest formula. Okay, have a great one, and I'll see you in class.